and I am live. That is good. So today is 17th of September 2025, Wednesday, and I am live and I am late. I started today's stream late. My bad. I had some stuff going on, but now, yep, let's just dive into it and solve dynamic programming questions from CSES sheet. And today is also a contest, so let's see how it goes. And yesterday I also did range query things, and this question where I have to find the minimum value in the range. This uses sparse table, and coding that was pretty nice. Yep. And now on to dynamic programming. This one needs some optimization. I do not yet know how to do that. And now let's like not jump our towers and choose a question that should be solvable. I guess right now this one is the one that has been solved by most people. Yep, let's do that. Dynamic programming, cool. And again, I'm really sorry for being late. I do not want to be late, but I am sorry for that. P4 Tmux 5. Shit. Yep, this is the one. CDDP. Yep, start new vim, and there are always updates in new vim. I even wrote a script which would tell lazy if there is some update, then just do them automatically, but it just doesn't listen. I don't know why. But here we are. CSES. Let's go. This question. Your task is to count the number of ways numbers 1 to n can be divided into two sets of equal sum. For example, if n equals 7, then there are 4 solutions. They can be divided into two sets with equal sums. Well, if n is 7, then the sum, and sometimes there would be no way to divide them in such a way, I think. uh, for the first 7 numbers, it is going to be 7 into 7 plus 1 divided by 4, 28. So this sum should be 14, 10, yes, 14, and every sum should be 14, I think. Yes, this is also 14, and this is also 14, and this is also 14. So this is very similar to coin change, and I can just, given a set, given numbers from 1 to n, how many ways can I get a sum that is half of the sum that has been, okay. So yeah, that is cool. The thing is here, just the number of things, the number of numbers that have been provided is quite a bit large. It is 500. And okay, and my target sum is going to be n into n plus 1 divided by 4. That is going to be my target sum. And when n is 7, so 7 into 8 divided by 4 to 14, my target sum here is 14 for every set. If I can just get some elements which sum up to 14, then it is cool. And shit, not just 14 divided into two sets of equal sums. Yes, 14, 14, 14, 14. I thought that maybe I do not have to use all of them at some point, but if I don't, I would have seen a set containing 1, 2, and on the other side 3. But yeah, so both the sets will include all of the numbers. That is cool. And n, C in n, and the thing is, what if n depending on n, what if the sum is not divisible by 4, not divisible by 2, the sum of the first n numbers? For 1, n can be equal to 1, then there would be no way, no possible way. If n is 2, then the sum is 2, and there would be no possible way to get us equal sum. Well, then I can just return 0. Yeah, cool. So, yeah, long, and the maximum sum that is going to be, since n can be at max 500, 500 into 500 by 2, 250, 250 by 2, 125, or 500 into 501 divided by 4, 500, 500, 25, 250000, and 2500, 250500 divided by 4. That is the maximum sum that I would like to have. And when I do this, 1, 2, 5, 2, 5, 0, 6, 2, 1, 2, 5, 62,125. That is the maximum sum that I would like to have. Hmm. And this is like the coin change problem, just that the number of coins is quite big. So it is fine. It is fine. This is totally doable. And let's do int target is going to be n into n plus 1. And then the whole thing divided by 2, divided by 2. That is going to be the target, and the number of things that I could use. No, that is not going to be the target. The target is going to be this thing divided by 4. And also this should be float, because if the thing is well, okay, let's just use 2 here, and if tar divisible by 2, if tar is odd, then I can just return 0. Long, let's equals 0. If tar is target is not odd, then do something at the end, otherwise just return res. And now this, so tar is even, and we would be able to read something. John Wick, hello, John Wick, a man of a strong man. John Wick, shit, you have 3 things. John Wick has 3 things, and those things are, how can any human being forget what are the 3 qualities that John Wick has? They are commitment. Shit. John Wick is a man of commitment, a man of focus, and sheer fucking will. And target. If this is doable, then we will do it. So this is very similar to the coin change problem. Not very similar. It is literally the coin change problem. And the number of coins that we have, which we can use. But the thing is, we can only use 1 coin once. Yep, that is the problem. So for int I equals 1, 1 is the smallest number of coins that we can use, going till n I plus plus. And how is our data going to look like? Okay, let's write a recursive function for this. So let's define a function f, which is going to take in sum, can I reach this sum using the first, let's say, subset, first I elements? Yes, I can if, first of all, for this, if s equals 0, then return true. Okay, and then if s is not equal to 0, then f s minus I comma I minus 1, or this is or f s comma I. Either we include this thing or we do not include this thing if s is not equal to 0. And since this thing, this and I minus 1, this thing only depends on I minus 1, therefore, and also it depends on the current s or the s that was before. So we can internally, we can use a singular vector, one-dimensional vector. We will call it table, and it will have n plus 1 elements. And initially we are going to say that answer is true, but we have to find out how many number of ways there are. So yeah, so when this is the thing, we can say number of ways, no matter how many points we are using, is 1. That makes total sense. And I will start going from 1. Yes, when we are using only one coin. And yep, when we are only using one coin, then what are the possible sums that we could reach? No, no, no. Okay, and then internally, the second loop, int s equals n, right? And yeah, s equals n, it will start with n so that we do not use the same coin again and again. S equals to n and s lower than, is this correct? While s is greater than 0 and s minus minus. So here we will have tab in our table using the ith coin. It would be possible either we do use this ith coin or we don't, and this thing, or tab. I think the table should have s instead of this. Yes, table does have s. No, no, table is not equal to the target. The size of the table, I think, should be equal to the target. Yes, so that, yes, I think that the size of the table should be equal to the target. Yes, so that initially this thing stands for I equals 0 when we are not using anything. And when we are not using anything, let's say when we are using a coin of 1 and S0, it is possible to reach S0, and there is only one way to reach S0. And a sum of 1, there is only one way to reach a sum of 1. And for 2, 0, 0, 0, 0, 0, everything else should be 0. And then when we are at I equals 2, when we are using the first 2 coins, and when we have a sum, shit, this is not or, this is going to take addition of the last thing. Yep, tab I or target. Yep, using whatever the current sum is, S, how many ways are there to reach that sum using the first I coins? Yep, and it should be equal to tar S should be equal to, like, if we are at sum 3, yeah, so 3 minus 2, whatever the value is there, plus, yeah, so that is cool. You can say initially when we are not using anything, there is only one way to reach that target. And also we have to avoid double counting, and we will not double count, because when I am done with one, I'm not seeing using one again. I am only using two. So this should be cool. This should work. Hopefully. Hopefully. Yep. So tar s will be equal to either I use this current coin or I don't use this current coin. So tar s plus equals tar s minus I, which is the current coin, and then tab s percentage equals m, take the remainder, const and m equals 1e9 plus 7, because that is nice. And if I do not use this current coin, if I do not use this current coin, then yeah, then we will be where we were. I think that is good enough. And then at the end, we can return tab tar. Okay. The big movement. No, shit. Ref is equal to tab tar. Ref. Yes, of course, that is what we expected. Okay, application binary interface error, that does not make sense. S equals star, and that is the size of our vector, so there should be no problem there. Tab LSP start plan D, and there don't seem to be any errors. Res, yep, star even is star even. And if it is, which it is in this case, we go in here. And what does tab I represents? Tab I is number of ways to reach some I. Yep, number of ways to reach some I. So to reach some of 0, there is only one way, right? And then we are saying when we are using the first coin, how many number of ways are there to use to? Yeah, uh, yeah. Given already this vector, its initial state, how many sums can we reach using the first coin, 1. And here sum should be initially sum, right? Yeah. This value tab s would increase only when tab has some value, only when s equals 1, and that would be the only case when it is increasing and nothing else. Yes, and here also this thing, when I do this, while s is greater than I, right? My bad, that was a mistake. Let's stop. Let's see. And 0 is pretty cool. Let's see, let's see. What is the vector? And that is very bad. That is not really good at all. Less than and equal to. Okay, 1. How many ways are there to reach a sum of tar? And the target here should be 14, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Answer should be 8. 8 is like, no. Answer is 4. Whatever the answer is, divide it by 2. So there is some problem with tar. Yeah, tar divided by 2, and here rest equals this thing divided by 2. Cool, cool. That does work, and hopefully that is also correct. And as always is the case, before submitting this, I will first delete the whole code and then submit it. And this is very basic, not basic, but I mean, it did took me some time to write this down. This is not very basic, but yeah, this is using a couple of things. This is using only one-dimensional vector to represent the state of our DP table, and that is a nice optimization, which we don't usually do. And the fact by which I am choosing what is the target and everything else, I think that is also not very obvious. So let me delete the whole thing and rewrite it again. So we are taking in n number, this number, right? And this n says that we have all the numbers from 1 till n. So if n is 7, then we have all the numbers from 1 till 7. And our goal is to divide all of these numbers in two sets. And the sum of all the numbers in two sets should be same, right? And we have to include all the numbers. We cannot just say, let me just use 1 and 2 from all the 7 numbers that I have. Nope, we have to divide all of those numbers into two different sets, and their sum should be same. And since we have to use all the numbers, here we know when n equals 7, and if we sum all the numbers from 1 till 7, what we will get is 28. Why? Cos n into this multiply. N plus 1 divided by 2, that is triangular number, sum of the first n numbers. So the sum is going to be 28, and our goal is to divide this sum into two different sets basically. So if our total sum is 28 and we want to divide this into two different sets, so 14 and 14, that is what we will get. But there are going to be edge cases. When n equals 2, then the sum is going to be 3, and we cannot divide 3 into two different sets. So in that case, answer is going to be 0, because there is no way to divide these numbers 1 and 2 into two sets, which would give the same sum. And the fact is that we have to use all the numbers. We cannot just say, let me use an empty set here and an empty set here, and now the sum is same. But we cannot do that. We have to use all the numbers. So that is it. So here, when we take n, we will first get this sum. This sum of the first n numbers, which is going to be, let's say, let's call it tar, and it is going to be n into n plus 1 divided by 2. And let's also say long. Rest is going to be our answer. Now, if this tar is even, only then can we divide this into two ways, into two different sets. And if it is odd, then we cannot divide this in equally into two different sets. So what we will do is we will check if it is even or not. So if not, tar remainder 1 and 1. So what is happening here is we are taking and of tar with 1. And tar, if we represent tar in binary representation, whatever the binary representation of that would be, if the least significant bit, if the first bit right here, if it is 1, then tar is odd, right? And if it is 0, then tar is going to be 1. And when we are taking and of a number like this, if we take this numbers and with 1, if the last digit is 1, we are going to get 1. If the last digit is 0 and we are taking its and with 1, then we will get 0. So this number should be even when the last digit is 0. And if I take the and with this number, I will get 0. And here is the same thing that I'm checking. If tar and 1 is not, which means if I take and of tar with 1, if I get a 0, then it should be even. And if that is the case, then it should be possible. But in any case, we will output the response. So at this point in the code, we know that there is an answer which is possible. So we will initialize our vector. We will call it tab. And we want to see how many different ways are there to reach the sum of target. And we are saying that tab I is a number of ways to reach the sum I. And number of ways to reach the sum 0 is 1, because you do not choose any coin. That is your answer. You do not choose any coin. So now we can begin. When we are using the first I coins, I equals 1, starting from 1, when we are only using the first coin, it will go up till equal to n when we are using all the coins. And when we are using the first I coin, we will start to iterate from s equal to tar. How many ways are there to get to a sum of s using the first I coins? And we will do this while s is greater than equal to I. If s is smaller than I, then we won't be able to get to that. We won't be able to use this current coin, this current ith coin, to get to this sum, because this sum is smaller than I. We cannot do that. Now it's my finals, and we are going to update recursively. Tab s is going to be tab s minus I, not equal to, but plus equal to. And we are saying tab s right now has the number of ways to get to the sum s using I minus 1 coins. And if we do use this ith coin, then tab s would be reachable using the earlier number of ways it was reachable, plus now new number of ways, because we have the ability to use this ith coin. And since this thing could be very big, we are going to take it mod const m int m 189 plus 7, and at the end we can say res equals tab tar divided by 2, and y divided by 2, because when you have one way to reach a particular sum, then you are not using all the rest of the coins to get to that sum. And since the total sum is, let's say, the total sum is Sn, the sum of the first n number, and your goal is to reach a sum of Sn divided by 2 using some subset of the first n numbers. So you used some coins, some I coins, to reach this sum Sn. And when you are using some coins to get to this sum, there are going to be some coins which were not used. And if you take all the coins which were not used and add all of them up, their sum would also be Sn divided by 2. Why? Because the total sum is Sn and you are only taking numbers which sum up to Sn by 2. Then you are leaving out numbers whose sum is Sn by 2. So but you don't want to do that. You are considering these two ways as one way, because when you are using some coins to get to a sum of Sn by 2, you are at the same time using those not used coins also to put into the other set. So therefore you have to do divided by 2 here, and hopefully it works. Hopefully, hope. Okay, 0 is messed up. 0 is messed up. 0 is literally messed up. Okay, 111 is uh, tab size is star plus 1, and the number of ways to get to a sum of 0 is 1 for int I equals 0. Mm, this is supposed to be wrong. This is supposed to be correct, but yeah, it is not working. Okay, we start with S equals target, the number of ways we can reach the target, and then we subsequently reduce the target by 1 every time. And we are also updating our table with the latest values, the latest things on the market. And then we are also updating the response to be equal to tab tar divided by 2. Yes, that is awesome. Yes, my bad. I am sorry. Our target, when we have confirmed that our target is even, and that Sn, that this number Sn is even, that it is divisible, we can divide this Sn number into two parts, Sn, and both sum up to Sn by 2. When we have confirmed that, then our target has to change, divided by 2. And what I like is, when you want to divide any number by 2, what we can do is right shift that number by 1. And this is just the syntax to right shift a number by 1 in C++. Still wrong. Tar, uh-huh. Ah, if tar is even, which is n into n plus 1 divided by 2, if this thing is still even, which is what we are checking here, and then do this. Okay, tab 0 is 1, yes. Tab as in table, 0 is 1, and I equals 1, I less than equal to target, yes. Ah, shit. My bad. Because we can use all the coins, all the coins, all the coins. But it's still, if we were not using, that makes sense, because n target is greater than n. That is why we got a higher answer. Cool. Let's submit this and see if this works, or maybe I'm stupid. Let's see. CSES DB. What is the name of the question? Two sets, two C++ 20, and let me hold my breath. Okay, wrong answer, wrong answer, wrong answer. Maybe why am I getting wrong answer? Maybe at some point this thing becomes very big and cannot handle this big number. Hmm. I think that might be the case. This thing is very big at times, but hmm, that might be that cannot be it. That cannot be it because we are always taking modulus with m. Logically, everything is correct. There might be some syntactical mistake. Let's actually see the thing. Okay, I outputted a higher number than the thing required me to. Okay, 107, 107. And also wrong answer for this. See, 0 is at times the correct answer. Yo, bro, how can I start code forces today? I randomly tried solving 1000 but couldn't solve it. That is fine. You can start solving from the CP31 sheet from 800 level. You can go to this sheet and start solving questions at 800 level. That would be nice. And I'm going to tell you, if this is your first competitive programming thing, then it might be pretty hard because it was also very hard for me when I solved my first question. And I did solve my first question on stream. You can go and watch that. And this is the question, the first question. Halloumi boxes. Halloumi is a type of cheese. And yeah, you can begin from here. It is nice. And do not feel bad if you are unable to solve a question. Just learn, right? Do not feel bad if you are unable to solve a question. Okay. So let's try with our customer input. G++. Yep, of course, we are going to use G++ subset and G++ compiler dot slash out 117. 0 does not make sense. Wait, 107, 107, 83, which is what we output. Okay, that is still wrong. Ah, wait, shit. The sum might be very big. This thing might be actually very big. Yes, you never know. 107, 107. Still, okay. That was not the thing. That maybe that was the thing. If I'm multiplying long by long. Wait, this is not even that big. Nah, nope. This wouldn't be that big. So there is supposedly some other mistake. There is supposedly some other mistake. Tab long. Yeah, the wrong answer like literally does not make any sense. Here my answer is about half the actual answer. Wait, it might actually be literally half. No. There's some other mistake. 100. 12 g plus plus / out 112. Yep, it is still wrong. Not equal to the correct answer. Yeah, everything seems ad hoc. Thanks, man. Yep, welcome. Just do not worry. You are like supposed to be unable to solve some questions when you start. And the only reason that you are unable to solve a question, that would be because you are not very familiar with the thing. This is your first time. So yeah, fine. Like I'm unable to solve this question. I've been doing competitive programming for 3 months at this point, and this is a dynamic programming question. There is something that is wrong. Uh, is there a mistake with this target? Dot slash out 500. I don't know if was there ever a 500. Okay, there was, and I outputted the correct answer. So there is some logical mistake. Maybe. Wait, when it is 500, the answer. Okay, it is big. It seems to be bigger than this number. I guess this might have greater number of digits. It is 451. 451. Ah, yep. When the question says 451, the answer is bigger. Yes, 69. No answer for 69. Wait, if there is 69, there might also be 420. Okay, there is no 420. My bad. 137. Okay, 137 it is in my name. Okay, it is 3 times, and all the 3 times it is in my name, not in the question statement. Okay, why am I getting a wrong answer then? When I take and I am checking if it is even, and if it is even, we divide this number by 2 and we do our thing. And target is also long, so that shouldn't be any problem. And this thing is integer, and integer is very sufficient, very like capable of holding a number this big. And s is also very sufficient. Like it is literally sufficient. I don't even have to do this long thing. This here, a division by 2 seems like a bad thing. Let me, this thing will be right shifted by 1. Is this the correct syntax? LSB start, client D. Yep, LSB is not giving any errors, so that is cool. G++ dot stack out 107 is still wrong. Uh, have you given any contests? Were you able to see a growth? Yes, I have given a few contests. Batman. Should we have Batman? We have John Wick. We have Crocodilo. That is amazing. Yeah, I have given a few contests on Code Forces. Code Forces is right there. Today is also a contest, a Division 2 contest. And it might be like, maybe it might be too soon for you to give a contest. But yeah, today is a contest, and my rating is at this point 1295. And more than growth, the main thing that I have gained from giving contests, and a thing that is like very important, not just for competitive programming, but for life, even literally life in general, is I lost a lot of rating. And that, like, that that made all of this very real. I felt very real. At some point, I lost a lot of rating. There was a contest. Yep, in this contest right here, I lost 114 rating. and I felt devastated. And I think the experience made me much stronger. And I think everyone should have experience like that so that they are prepared, so that their mentality becomes stronger or something like that. Yeah, so even more importantly than growth, the loss was very important. But it doesn't work, doesn't work. Okay, my answer is actually smaller than the correct one. And wait, 1, 2, 3, 1, 2, 3, 1, 2, 3. That is smaller. 1, 2, 3, 1, 2, 3, 1, 2. That is smaller. That is like 589 million. Well within the range. Hmm, S. The mistake has to do with something. S could be a big number. Let's output tar and g++ c out dot slash out 500. What is the target? Target is this, and yes, it is not very big. It is not very. Yes, it is fine. It is fine. It is fine. It is correct. It is correct. And into n plus 1 by 2. Dot slash out. We were getting wrong answer for 107. The target is this. Why? Is there some? I think there is no mistake in this part. And if there is some mistake, it has to be with the other logical part. I am taking in n, and that is very good. And then I multiply n by n plus 1 and divide by 2. That is the target. That is the sum. And then response equals 0 initially. I don't know. Hey bro, hello. Well, what extension is this? Is it? It's okay, bro. Up and down, a part of life. Yes. We just know it logically, but we do not feel it very often. And I guess code forces is the way to feel it very often so that you do not forget that life goes up and down. In code forces, which extension for zooming in or what thing for this? Arrow ready. Yep. Today most great number theory problems are ad hoc. Uh-huh. Yep. Ad hoc. Some problems that doesn't depend on it. Yep. 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 For rating, it is code forces helper. This one, code forces helper for rating of questions. Wait, don't you get rating? If I go to some submission, yes, today is a contest, and I should have a column right here which shows me the ratings. Doesn't work. Isn't working right now. It ain't working. But yeah, and contests is cool. CPL paper, I don't get like this in my profile. Wait, what am I getting in my profile? This thing? And also contests right now are not my like the main priority. The main priority right now is wait, rating graph. I think it is you will be able to see this rating graph even without anything. If you go to like incognito, this thing, you still see it. Okay, the other one, this one. Hmm. Guess you should be able to see it. And I can compare my rating with Mr. Gennady Korotkovich. Hmm. Almost there. His rating is here right now. I am here. Almost there. Mm, just a little last push. That's all is what is needed. And I'll be there. Almost there. But I can check with Dominator 69. Dominator is 069. Yeah, almost there. Yeah. Uh, yeah, yeah, yeah. Yes, I'll be there. I guess that is by the extension. Contest participation checker, show submission rating, high tag, multi-user graph. Yep, this is the one. Multi-user graphs. I have now made turned it off. I shouldn't. Yeah, now it is gone. Now it is gone. And if I turn it off, we are back in business. That is cool. And now that thing. Yep. Umnik is nice. I read his article. His article on how to solve a question. Right here, catalog. I guess it was 11 years ago when he wrote the article, how to solve a question. 7 years ago, how to read problem statements. Umnik. And yeah, he began this article in a very funny way. But Umnik, we all know how to read. We have our whopping 2 months of experience. Oh, my sweet summer child, my experiments show that many people with kind of cool achievements like medals on ROI, return of investment, don't know how to read statements. But don't worry, I will teach you. We probably won't, well, probably you won't understand anything because you didn't try to understand anything in your life. You expect all hard work to be done for you by someone else. Let's start. That is how you start. You probably won't understand anything. That is how you start an article in which you are trying to explain something to someone else. That is umnik. Wrong answer. Wrong answer does not make sense. Wrong answer does not make sense. Not a lot of sense. This maybe write the thing again. I don't know. Long and turn off the LSP. Okay, LSP is not even giving any errors. LSP stop. Long C in N and yeah, tar equals N into N plus 1 divided by 2 and long this equals 0. If not N and 1, if N is even, then tar left shift. Wait, I didn't mess up the left and right shift probably. Right? Yeah, I didn't mess it up. So that is fine. And now the thing begins. Okay. Vector, let's just say long called table star plus 1 elements and tab 0 equals 1 const in m equals 1 e9 plus 7 and 12. Yep, for int I equals 1 I less than equal to n, that is all the numbers I can use, I plus plus. And let's just go literal bonkers. Long s equals star s greater than equal to I and s minus minus, and what we will have is star s equals tar s minus I, and tar s remain s remainder by n. Yep. And before here, s equals tar. Shit, I messed up a little bit, only a little bit, not much. Here, tar has to be substituted with tab globally. And here, the same thing here, res equals tab tar divided by 2, which I do not like. So I think that is the syntax for left shift. Cout res end line, which will append a new line and also flush the output. Zero is like literally something I was waiting for. Shit. I hope I'm not doing anything stupid. I think I am doing something very, very stupid. Tab 0 equals 1, I 1 till n, and while s is greater than equal to I, huh, tar right shift tar divided by equal to 2. Okay, my bad. If we have to check the validity of tar, we can go back to our OG syntax here and also the OG syntax here. Cool. And yep, let's try to submit this and hope that this works. This is not teaching, this is roasting. Yeah, yeah, bro knows too much truth. Mm, 2 sets, 20. Yeah, submit, pending. Mm, It is giving wrong answer again. I guess, yeah, I can put this one in review or something, and then I will come back to this later at some point. I do have the whole state in my head, but why is it giving the wrong answer? It does not make any sense. Mm, What could be the error? S minus I. If I do use the ith coin, that would be the number of ways to get up to the S coin. Uh-huh. Wait, is there some logical bug? Yes, I'm trying to find. Yes, we are trying to find the number of ways to get up to target. Yes, and answer should be this thing. Dot slash out 107, 17 billion or something, and the actual answer for 107 is 589 million. Yeah, how to write shift n p plus plus. That was the correct syntax. Value and count position, yes. Right shift this value this many times. Yeah, that is like absolutely cool. No problem with that. And right shift does do the division operation. Yes. And tab 0 is going to be equal to 1. Mhm. And we are only adding numbers here. So that shouldn't be any problem. Let's say this. Let's say this 107. Now the number is pretty big, right? And if we tab star remainder with m before returning 107. Wait, we are getting something totally new because it might have overflowed before. Yep. Tab s remainder with m modulo m. Now we won't be getting a very big number. Yep, 107. Yeah. Okay, so we can skip this for now. And by skip, I mean I will do this on my own later on the stream, maybe. Yep, and this doesn't make sense right now. It is not happening right now. Increasing subsequence. Let's do that one. You are given an array containing n integers. Your task is to determine the longest increasing subsequence in the array. And there are two things in this. We can easily implement a solution which takes n log n square time, but we want an algorithm which takes n log n time. And writing, I do not know how to write an algorithm that would take for this question n log n time, because when, let's say, I have another vector dp array, and this thing has a bunch of numbers same as this, and for each corresponding number in these two, let's say I will have dpi dpi, this, let's call this table dp. dpi should be equal to the number of increasing sequences, the number of increasing subsequences, yeah, subsequences which have this ith number ai at the last. This is a vector a. So when I am at some index I will look at for which indices can this I be a be the could be appended at the last, and then among those which number has the biggest value. That is all I need. But how? So when I'm making my choice, when I'm pairing this current number up with some other number before, the only thing that matters is the value of that number, like the literally the number which it is. Only I will be considering the numbers which are smaller than this number, and then among them which number has the highest value. That would be the thing that I'm looking for. So there are two things that this number depends on, I and dpi. And if I perform binary search on one of these numbers, then how can I perform binary search on the other part where I'm looking for the other side? Yes, when I'm looking for the maximum dp value. if I have 1, 2, 1 here, and here I have 3, then this 3 should go with these, with this number and not with this. Yep, and this 3 could be paired up with all of these numbers. I need a log n time algorithm to find the best choice possible, and then make that choice and move forward. And a log n time algorithm would be much preferred. Maybe using a dictionary? Nah, no, no, no. Because this value can be very big. Yes, I do not want to use a dictionary. It would be very big. And what I need is to first of all see with which numbers is this current number pairable, and among those numbers, which one has the highest value. Like here, I cannot just take the rightmost one because this number is pairable with 3, but and also this is the rightmost one, but this is not pairable with other numbers. So that is not very good. And yeah, so I need to find log n time algorithm. And this problem, that is to find a log n time algorithm, was also there in CLRS when we were reading the dynamic programming questions. This was one of the questions at the end of the chapter. And yeah, I didn't do this then. I did give it some thought, but I was unable to come up with a solution, and now it is right here. Defined. Okay. Yes, and there are only two factors on which my choice depends on. And the two factors are what is this, literally, what is this value? Let's call it AI, and also what is its DP, what is the value it has in the DP. So for this, only one condition has to be true. And yeah, let's say I'm currently at a number whose index is J, or let's call this number like literally the number, not the index, the number X. So what I need is AI has to be smaller than equal to X, first thing. And for all of these I want the maximum DP, maximum DP. Yes, this is a this is a P, maximum DP for all the numbers for which this thing is true. And using a set, I would be able to find for which numbers is this thing true. But but then internally, when I'm looking through those numbers, they are not sorted according according to, wait, I am getting some idea, according to their DP values. I guess this DP table doesn't need to be very strict like it is as a vector. This mm, this DP table doesn't need to be a vector. Yes, this can be anything. This doesn't have to be a fixed vector. This could be a, do I need some policy-based data structure here? Nope. No, no, no. I mean, I want this thing to be sorted according to two things. First of all, according to the AI value, so that I would be able to find with which numbers is my current number pairable with. And then this, and all the numbers which this current number is pairable with, they should have their DP sorted out. It may be some, maybe I can do something when I add, when I see one, when I initialize my thing, the longest increasing subsequence is of size 1. And then when I see two, when I do see 1, for this answer is 2, because this one could be paired up with this one. So I can say, if I do see a number whose length is 1, 2, or anything, pair them up with this number. Okay, and its value is going to be 1. So when I do see a 2, I can say, if I see any number with whose value is 2, 3, or something, pair them up with this number. Yes. And when I see 1 again, this one can be paired up with this. And now, yes, okay, gears are turning. I'm trying to think of a logarithmic time approach for finding the best choice possible. Some choices are invalid. Wait, I think that is actually correct. And I can use a map to store this value. Yes, a map would be nice. Aha, yes, a map. Shit, literally, a map would be nice to store this. When I'm at 3, I can, and then let's say I see 2. Let's take this example. Here the answer is 4. How do I say that this is correct and go on with this number? This is the number, these are the numbers. Yep. And this is what we have. And when we are initially here, we will say, if you see any number, yeah, in our map, put 7 and its value is 1. Then when we see 3 and we will look in our map, is there any value which is lower than 3? If it is, then cool. If it is not present, then add 3 with a value of 1. And then when I see 5, see, is there any value which is lower than 5? Nope. Yes, 3. So add 3's value, add 1 to 3's value, and put 5 here and 2. Yes. But it would, be bad. What if I have something like this? 1 1 1 1 1 1 1, and then 2, and then 3. When I have a bunch of ones, this one at the end would have a value of 1 2 3 4 5 6 7. This one would have a value of 7. No, this is right. This will give us the right answer. But what if we have 1 1, and then a 2, and then a bunch of ones, and then 3? What if this is our array? So when we are at 3, this 1 would have a value of 1 2 3 4 5 6 7 8. This one would have a value of 8, and this 2, since it could only be paired up with these ones, 1 2 3 4 5, would have a value of 5. And when I am looking for some number that is smaller than 3, I will get 2, and I do not want to get 2. I would want 8 here, because 8 is the best number here. And those numbers are repeating. Yep, they are repeating. 3 3. Wait, instead, s- I will, let's say, uh, since I know this 3 can be paired up with this 2, uh, yeah, this would be the edge case where the map algorithm would not work correctly. Any ideas about how I can write a log n time algorithm which can find the best choice for the current number to be paired up with? If I go with 2, this is what I have, and if I go with 1, this is what I have. So I cannot always just look for the biggest element to pair this with, like here 2. It feels like there has to be 2 binary searches. Log time algorithm which finds the best choice. Yeah, this doesn't make sense. No, this does make sense. It is just that I am stupid. I'm just trying to think of a way. Okay, let me just try to think of a way for a little while longer, and then we can just look at the solution. It is not too bad to look at the solution. Like, we don't have to feel bad about ourselves. And I think we do get the problem. The problem is we can very easily write a n square time algorithm to solve this question, longest increasing subsequence, where we are when we are at some particular element, like let's say we are here, this is our ith number. We go through every single number with which we could pair this number with, and we see which one has the highest value. But that takes n square time, and that is too much. What we need is n log n time. This is very much preferred. If you could find something like this, it would be pretty cool. We cannot use a map because a map, what will we cannot even use a set. What we need is, first of all, we have to see all the numbers with which this number could be paired up with, and among those numbers, which one has the highest value. Yes, which one has the highest value. And when I know in my table that 1 is 8, I should somehow, when I'm here, I should be able to know that if there is any number whose value is either 1 or greater than 1, this should be paired up with this number, which has a value of 8. And for this 2, every number which is 2 or greater than 2 should be paired up with this 2. No, 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 no. No, it should not be. It should be paired up with 1 and not this 2, because this, if they could be paired up with 2, they could also be paired up with this one. And if they could be paired up with any one of these, 1 or 2, they should be paired up with 1 because 1 has a higher value. So that is something. Yo, 2 pointers maybe paired up with binary search, but like specifically how? Because I need 2 binary searches, right? First to find out the numbers with which I could pair this current number up, and then among those numbers, which number has the highest value. Because if I wait, I could 2 pointers. Maybe we go in the opposite direction. We begin from the end, and what if we begin from here? We'll begin searching from here, and we can pair this number with every number that is either equal to this or bigger than this, or yes, or bigger than this. Then pairing this up with the smallest number would be the best. Shit. Then pairing up with the smallest number would be the best. No, 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 it would not be the best, because what if we have something? Wait, it would, no, it would not be. Yeah, that also doesn't seem right. Because what if we have a sequence like this, 3 3 3 1, and I am currently here, I should pair this 3 with the 3's, and wait, by smallest we mean the smallest number with which this current number could be paired up with, and this number could be paired up with a1 or with the 2, and the smallest among them is a1. And if I do choose the smallest, with which this number could be paired up with, then yeah, then it might be bad. Yes, then it might be bad. Just in this case, like 1, 2, 4, 5, 1. Oh, shit. The smallest number with which this could be paired up with. Yes, 3. What if I have something like this? Instead of pairing this 3 with this smallest number with which this could be paired, I should pair this 3 up with 4, which is paired up with this 5. So that would be the longest subsequence here. Yeah. So yeah, we need to find a constant time logarithmic time algorithm to find the best number. Let's write the dynamic table for this. Maybe that could help. That could actually help. Let's write the DP table for this. Because it would be very good if I am able to figure this out on my own. It would be actually pretty cool. These are the numbers, and we would have something similar here. 7, 3, 3, 5, 3, 6, 2, 9, 8. Oh shit, they change in different rates. Shit, this thing does take a bit of time. Yes. Mhm. And we are saying that dpij, where I is this row and j is this, dpij will say, what would the answer be if I pair up this ith number with this jth number is the last number and ith number is the number before it. Yep, something like this. And if that is the case, then we like won't be able to fill a lot of this table because I cannot pair up this 7 with this 3. The order does also matter, also does matter. Okay, so when I pair up this 7 with 7, I have 1. When I pair up this 7 with 3 as the last number, is 0. With 5 as the last number, 0. With 3 as the last number, 0, 0, 0, 1. And with 2 actually. And when I pair up 8 and 7, 2. Can I pair up this 7 and 3? Nope, these are going to be like literally symmetrical, these things. So 0, 0, 0, 7, 0. 7 cannot be the last number, right? Because how? So this part this box can be filled, but this one where we are trying to say that 3 is the last number, it is not possible to fill this part. So all the thing below this green line is not possible, and this diagonal would only have 1, 2, with this 3, 2, with this 6, 2, 0, 2, and 2. And when I'm trying to pair this 5 with the 3, we cannot do that. Here answer will be 2, here answer will be 0, here 2 and 2. And when I'm trying to pair up this 3 with this 6 as the last number, since this 6 is greater than this 3, right? And we know that the maximum value in this 3 column is 2. So we also can pair up this 3 with this 6. So answer should be 3. And here when we are trying to put this, answer will be 0 because this 2 is smaller than 3. And for this, answer should be 3 because the highest value in the 3 column is 2, and this thing can be paired with 3. Here answer should be 3. And now when I'm trying to pair up this 6 with this 2, since 2 is small, and we also see that in the 6th column the highest value is 3, and with this 2 answer should be 0. With this 9 answer should be this greatest value plus 1, so 4. For 8 also it is 4. Then for 2, when I'm trying to pair up with this 2 with 9, the highest value in the 2 column is 1, so 1 plus 1 2, and here again 2. And when I'm trying to pair up this 9 with this 8, it is not possible because 8 is smaller than 9. So answer is 1, and in this whole table the biggest value is 4, so answer should be 4. But this thing takes n square time, which is something we do not want, literally, which is something we do not want. So we need to be much more clever than this. When I am, so what we need is, we need to be able to make this table, we should be able to derive this table, yep, in logarithmic time. So when I am here, and yeah, yes, when I am here, I know that this number, this current number, this number 6 can be paired up with 3, 5, and 3. And among these 3, this 5 has the greatest value 2, and this 3 has the greatest value 2. And I don't even need to store all of these. I only need to store their greatest values. So here the greatest value is 1, here it is also 1, here it is 2, here it is 2, here it is 3, here it is 1, here it is 4, and here it is 4. So this, when I'm here at the 6, I can pair the 6 up with 3, 5, and 3, and I should pair it up with 3 or 5, does not matter. The highest value is 2, which is same for both. So I wouldn't know. I guess we can at this point look at something and read some things. Longest increasing subsequence, and we can go to CB algorithm. Yeah, it would not benefit us, I guess, if we spend more time on this. For this 6, may be, I don't know. No. We'll have to look here. Longest increasing some subsequent increasing subsequence. See this. Yep. We are given an array, and I mean there is no problem in the dynamic programming part. The only problem is in the optimization part and how to optimize the dynamic programming solution. Because here we know the choices that we have, and we also know the value which we will get as a consequence of those choices. And the only part that we have to optimize is finding the best choice without going through all the choices. That is what we have to optimize. We are given an array like this. The task is to find the longest in strictly increasing subsequence. In longest increase is okay, it is strictly increasing. So that does change a lot of things because our okay, now I'm trying to think of where this could go wrong when I'm pairing up with the biggest number possible. If I am currently at 4 and 3 was my first number, then 1 and 2. I should pair this 4 up with this 2. Yep, I should pair this up with this 2 instead of this 3. 3 would have a value of 1, 1 would have a value of 2, 2 would have a value of 3. And this is almost like pi, 314, 314. This 2 is bad here. Okay, let's read. Strictly increasing subsequence in array A. Formally, we look for the longest indices such that this thing is true. In this article, we discuss multiple algorithms, n square algorithm in dynamic programming. This one we do know, we can like literally implement this right now. Let's implement this right now so that I'm not in some mental state and telling myself that I would be able to write it if I want, even though I might not be able to write it. And n, c in n, vector int a, size n, for in reference x in a, c in x, and int mx equals 0, and vector int res n, and for int I equals 0, I less than n, I plus plus. And now, yeah, uh, for int I, for int j equals I minus 1, and j greater than equal to 1, greater than equal to 0, and j minus minus, j will keep going back, and we will also initialize this dp I equals 1 if we do not pair this up with anything, and int dp I equals maximum of current dp I, or 1 plus dp j if aj is smaller, literally smaller than ai. dpi equals maximum of current dpi or 1 plus dpij. And yep, after that mx equals maximum mx or dpi. Out mx. Yep. I mean, this thing is surely going to. This thing is surely going to work. Yeah, it does work, but the time complexity is too high, so we cannot use this. Cannot use this. We need something better than this, than this n square time algorithm. Because I guess we are smarter than this. Not I guess, I know. Yeah. So dynamic programming is a very general technique that allows us to solve a huge class of problems. Here we apply the technique for our specific task. First, we search only for the length of the longest increasing subsequence and later learn how to resort to subsequence itself. Okay, we can also construct the subsequence if we want. We can have another array which would tell us with which number did we pair up this current number, and that would be nice. Finding the length. To accomplish this task, we define an array D, where di is the length of the longest increasing subsequence that ends at the element at the index I. Yep. Shit. That is some test tube thing right there. The longest increasing subsequence ends at index 4. So this is one indexed. Index 4 would be 1, 2, 3, 4. 4. Which ends at index 4 is 3, 4, 5. 3, 4, 5 is the subsequence. Okay. 3, 4, 5 is the subsequence with the length of 3. The longest ending at index 8 is either this or this subsequence. And both having length of 5. Okay. We will compute this array gradually, first d0, then d1, and so on. After this array is computed, the answer will be the maximum value in this array. So let the current index be I, that is, we want to compute the value di, and all previous values, these should be known. Then there are two options. Either di is equal to 1 or it is greater than 1. If it would be equal to 1 if it cannot be paired up with anything, with any element to the left consisting only of the element ai, and di would be greater than 1 if it could be paired up with at least 1. The sequence will end at ai, and the right before it will be some number aj. Yeah, yep, aj, which is smaller than ai. It is easy to see that the subsequence ending in ai will itself be one of the longest. Yes, one of the longest subsequence that ends in AI. The number AJ, the number AI just extends that longest increasing subsequence by number 1. Yes, yes. Among those numbers, which one has the highest value? Yeah. Therefore, we can just iterate over all j less than I. Yes, and take the subsequence. Yep. What is the maximum value for dj? J is, yep, j, while j is lower than I. If we combine these two cases, we will get the final answer for di. That is maximum of either one or this thing. Implementation, this is like parent I, j from 0 till less than I, j plus plus. And if it is smaller, if aj is smaller than the current ai, then find the maximum of di currently, and we did initialize I with a value of 1, so that is cool. Everything is initialized with a value of 1 and answer. Then we go through the whole thing and find the maximum value. That is also cool. Restoring subsequence. Okay, we can also restore the subsequence by keeping track of which j we are pairing this current number with, and then, yep, and then when we know which di is maximum, answer pos as in like position, and the first, yeah, everything would initially be equal to -1, and then answer, we are finding the maximum value, and where do we get that maximum value, and then using that position we just backtrack and find the best way, find the sequence which gave this thing. And alternative way to recognize, yeah, this is the thing that we want with binary search. In order to obtain a faster solution problem for the problem, we construct a different dynamic programming solution that runs in n square, and then later improve it to n log n. Yes, that is what we want. We will use the dynamic programming array. This time DL doesn't correspond to element AI, or to an prefix, to a prefix, I guess, to a prefix of array. DL will be the smallest element at which an increasing subsequence of length L ends. Huh, that is something, right? We will use the dynamic programming array DA. So they have changed the definition. Okay, this thing I was also considering this, but then I saw that here mm, this value can be very big. Okay, what are they saying exactly? We will use the dynamic programming D0 to n. Okay, we will have the size would be same as the number of elements. No, number of elements plus 1, because we are going till n, and 0 and n both are included. This time DL doesn't correspond to the element AI, or to an prefix of the array. DL will be the smallest element at which an increasing subsequence of length L ends. The small d, okay, if I, the smallest number with a length of the index. Initially, we assume that everything is equal to 0, and then we will again gradually process the numbers AI, then even. Okay, I think we should be able to write the solution just from this statement. They are changing the definition for the dynamic programming vector. They are saying DL represents the smallest number which will be the smallest element, not the index of the element, but the element which at which an increasing sequence of length L ends. Let's go with this. Let's construct our own DP array with this thing. Okay, when we have this, right? And let's say our DP array is this, right? And length is 0, 1, 2, 3, 4, 5, 6, 7. How many are there? 1, 2, 3, 6, 7, 8. So let's go till 8. And yeah, remove this whole thing. And we will do this professionally like this, right? And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And what is the longest sequence? When I'm at 7, I need to make the longest sequence with 7. And the longest sequence that I can have is the smallest number. Minus infinity makes sense. So when I am here, the best I can hope is to get a length of 1. So I will look at what is at 1, and there is initially minus infinity. And can I pair 7 up with minus infinity? Yes, damn well I can. Wait, then I will have to update this with 7, right? Because they did say minus infinity dp0, and for all others it is equal to infinity. Yep. Okay. Okay. The best length I can hope for is 0, because currently I am at a index of length 1. Index I plus 1 is my best hope, and I am looking for a length of I, and I in the DP array has value minus infinity, and I can pair up the 7 with minus infinity, and this thing would always have minus infinity internally. So minus infinity here, this is, wait, why am I making a 8? Minus infinity, let's use infinity, and here we would have 7. And when I'm at here, index I equals 2, the best length I can hope for, wait, I is 1 at this point. When I'm here, I is 1, the best length I can hope for is 1. And can I pair this up with 1? Nope. So I go left, and I pair this up with 1. And now the length that I do get is 1. So I change this 7, and this 7 has 3 now, because 3 is the smallest number which has a length of 1, where a subsequence of length 1 ends. And then I'm at 5. And this thing is infinity. Wait, is this thing always going to be in increasing order when I'm at 5? Is this thing always going to be in increasing order? Because right now every value is infinity, and when I'm at 5, the best thing I can pair this up with is 3. So I change this to 5, and yeah. Wait, shit, no. This thing will become 5. This thing will become 5. And when I'm at 3, I look for this, and this thing will become 3. The value here will become 3. When I'm at 6, I look for the largest value, that is in this, which is to the right. And this would be, here internally the values are monotonously increasing. But is this always the case? Okay, initially we can use induction here. We can literally use induction here. So initially we know that this vector has infinity in all the cases. So this is monotonously increasing. And now whenever I see a number, I find, so initially it is monotonously increasing, right? Initially everything is equal to, first value is equal to minus infinity, then infinity, 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 all the way. And when I see a number x, I am looking for the biggest number that is smaller than x. The biggest number that is smaller than x. Hmm. Yes, the biggest number that is smaller than x, and I will see that it is, let's say in this case, it is some number here minus, initially it is monotonously increasing, and I see that let's now talk in a general case. Let's say our array is monotonously increasing and I have values A, B, C, D, E, F, and they are all monotonously increasing. Now I come with X and I look for the biggest number that is smaller than X. And since we are saying by inductive hypothesis, using the inductive hypothesis, we can say that the number that we find, which is the biggest number that is smaller than X, it is going to have the highest index, because since this thing is monotonously increasing, the value just to the right of this D that we found, if there was any value, any element with a higher index than D, which was smaller than X, if there was any such value, then we would have chosen that instead of choosing D, since this function is monotonously increasing. And the value which is just to the right of D is going to be bigger than D or equal to D. And if it is bigger than D, then it would also be bigger than X, because if it wasn't, then we would have chosen this, but we didn't. So this has to be bigger than dx. So D has the highest index. Now, when we are putting the value, since whatever the index is here, I, the new length, when we add, let's say the sequence that ends at D is SD, we add to this sequence x as the element, as the new element. At the end, we add x, and the length of this SD sequence was I, this index. Now the new length is going to be I plus 1. And we know that E is greater than x or equal to x, greater than x. It is or equal to x. But whatever the case, we will put x at this index, and still this thing is monotonously increasing. So this is always going to be monotonously increasing, and that is crazy. That is crazy cool. Right, so by induction, this is always going to be monotonously increasing, which is cool. Induction. Okay, inductive hypothesis. Now we can delete the whole thing, and we can say and C in N, right? And vector int A size N for int reference X in A, C in X, and vector int, let's say response size would be N plus 1, and each value would be equal to int max. And since we are using int max, we would have to include C limits, and everything is int max except the first one, that is 0 equals 0. Yeah, because all AI values are greater than 0. Now for int I equals 0, I less than n, I plus plus, da da da. Yeah. So now what we have to do is apply binary search internally and find the biggest, we can use the binary search function provided to us by C, but there is a problem with using that, which being that it will not return to us the index, and it will return the value that we found. So let me implement my own binary search, left and right. L is going to be 0 and R is going to be equal to I plus 1. And we are saying that R is always out of bounds. And now, while R minus L is greater than 1, we are saying that L is always something that we can pair our current number with, and R is something that we can never pair up our current number with, because we can never have a length of I plus 1. Wait, we can never have a length of I plus 2. We can have a length of I plus 1 because when I am at index I, since I starts from 0, 1, 2, 3, 4, let's say I is 5, the biggest length I can hope for to find earlier is 5, right? I can never find a element whose length is 6 because I just haven't seen this many elements till now. So I plus 1. Yep. And int mid equals L plus R minus L divided by 2. And now mid if res mid index if if this thing is something that I can pair this current number up with, or we can say if this thing is greater than AI, then we cannot pair this up with I, so R equals mid. I don't like the word mid, substitute with mid with M, and else L equals M. And when we are out, L should be the answer, L should be the index, and what we will do is res I plus L plus I, L plus 1, L plus 1 equals AI. And int answer equals minimum. Res dot begin. No. We are looking for the maximum length to something that is in mx equals 1. Maximum of mx comma L plus 1, because L plus 1 is a length that we are able to have here. See out mx. Okay, it is working. Okay, let's actually even see what res has to say. Okay, it has to say quite a bit. Yeah, cool. Okay, let's submit and see if you got this or not. Let's see how it goes. And it would be cool. Okay, longest increasing subsequence. LCS. Okay, that is not the thing. Increasing subsequence, not longest, just increasing subsequence. This one. And C++20, that is cool. Hopefully, hope. Okay, a wrong answer in the first one. User outputted 1, which is bad. No shit. Now it is correct. Yep, now it is going to be correct because I was pairing up same numbers. It has to be strictly increasing. Strictly. Hope. Hopefully. Ah, okay, okay. That is cool. That is cool. That is good. Now we got the right answer. We got the right answer. Now we got the right answer. That is pretty cool. Okay, and yeah, today we have done this question and we tried to do the two set question, but we were just unable to do it. There is some logical or some error there. We were getting wrong answers for some bits. So we just did two questions essentially. And today I'm going to keep this a bit shorter and sorry for that. And today this is going to be the end for the stream. Just 2 hours. Just 2 hours. 2 hours is like very small time, very little time to be coding. But yeah, today this is going to be the end of the stream and thank you for being here. If you have anything to say in the chat, it would be nice. Yep. Yeah. Thank you for being here. Bye-bye. Bye.